Yes, sir.
Yes, sir.
Yeah. So I don't think it's any different. You will have to still do the same multiplication. Anyway, this one was 612 and then 73. So same multiplication you will have to do. But you should know this formula anyway, all right? LCM using this formula. So of course it will be same. 676. Okay. Let's take up more questions. One 148 by 185, simplest form. What does this have to do with the questions we have been doing so far? Can anyone explain to me?
We can represent it in the like multiples of prime factor.
Yes, we can just find the HCF of these two, and whichever is the highest common factor, when you cancel it with that or divide both numerator and denominator with that, it will get converted to the simplest form. Okay. Let's say, for example, if you had 27 by 63, if you want to bring it to the simplest form, what do you do normally?
3 into 3 into 3 into 3.
No, in general, what you do normally, you know that this comes in 9 table. This both these come into 9 table, right? And 9 is the highest factor. So when you cancel with this these two, numerator and denominator with 9, what will happen? 9 threes are 27 and 9 sevens are 63. So it will become 3 by 7, right? When you did the division by 9, which was the highest common factor, you bring it to the simplest form. Same thing you have to do here also. Okay, find the highest common factor and divide the numerator and denominator both, and you get your simplest form. Is that clear to everyone? What you have to do?
Yes, sir.
Okay.
Yes, sir.
So I will not do this time. You have to do this 148, 185. What is the HCF? Find it out and tell me. Mhm.
37, sir.
HCF is 37. Okay. Is that what everyone is getting?
Yes, sir.
Yes, sir.
Okay, that's good. So you have found the highest common factor. Now just divide the numerator and denominator both. So 148, you can divide it by 37, and 185 also divided by 37. What do you get?
4 by 5, sir.
4 by 5.
Excellent. Quick confirmation, all of you. Everyone is with me. Everyone understood what to do for this kind of a question.
Yes, sir.
Yes, sir.
So I heard only from 2 people. What about other people?
Yes, sir.
Yes,
4 only. Other people did not get their lunch today?
Yes, sir.
Sir, can you repeat it, sir?
Yes, sure. See, in this question, they are asking you to write this in the simplest form, right? Simplest form means what? You have to cancel this out basically, and bring it to the simplest form, which will not have any common factor between the numerator and denominator. So normally you will try to do this with on your own just by doing some simple numbers. You'll try with 2, 3, 4, 5 like that. But as you can see, 37 is the common factor, which is a prime number. So if you were trying to do this by the normal method, like trying to cancel it by 2 or 3, 4, 5, 6 like that, you would have had to go up to 37. So that will not work for big numbers like this. And sometimes you may get even bigger number than this one, right? So what is the best way to bring this kind of a fraction to the simplest form? You find the HCF. Okay, I gave you an example of 27 by 63, right? So if you want to bring this 27 by 63 to the simplest form, what do? You take the highest common factor, but normally you would know just by looking at these numbers, you would know that both these numbers are divisible by 9, right? Because these numbers are small. So we already know that these both of them are divisible by 9. So what we do? We divide 27 by 9 and 63 by 9 also. And what do we get as an answer? 9 3s are 27, so we get 3. And 9 7s are 63, so we get 3 by 7. Is that clear? So by dividing by the highest common factor, we bring it to the simplest form. So that is what we are doing here also. HCF, we had to find it. These numbers are big, so we can't do this calculation in our mind. So we have to do it using any of the methods we like. So either you want to do it with Euclid's division lemma method, but that will be lengthy, waste of time. So if numbers are small like this, just try to use the prime factorization method and find the HCF quickly. So once you have your HCF, just divide it by that. Both numerator and denominator should be divided by the same HCF, and you will get your simplest form. Confirm if you're okay now.
Yes, sir.
All right. Okay, so let's see another type of question. So we have taken HCF of 2 numbers this time. Let's take another question with 3 numbers now. So you have to find the LCM and HCF of 108, 120, and 252. 3 numbers. Do it quickly. Still not done? Someone should be done by now at least. What is the HCF?
Done, sir.
Completed, sir.
HCF is 12.
What is the HCF? Repeat again.
12, sir.
Okay, I heard from Nitya and was that Pragati?
Yes, sir.
Okay, anyone else has completed?
Yes,
Completed.
sir.
Sir, and LCM is 3000.
Okay. What is the LCM? Tell me.
216.
LCM is 216.
Sir, 3000.
Charan, I'm not able to hear you. There is problem with your audio. You can type your answer in the chat window. Other people,
Sir, 24,160, sir.
how much? 24,160. Is it this one? Ritesh?
Yes, sir.
7560.
7560.
Okay,
Yes, sir. 7560.
Aditya and Pragati, you are saying 7560. Okay, Adi
Sir,
and
7560, sir.
okay, that is Harinarayan.
Yes,
Sir,
sir.
7560.
Okay, Harinarayan and Kavya also 7560. Other people who have got a different answer, all of you check your calculations. Did you make any mistakes?
Sorry, sir. I didn't multiply the 7 and 5.
Yes. So the right answer is 7560 actually. Okay. HCF is easy. Everyone gets that. Correct. Common factors you need to look. Something which is common in all three of them. 2 is common here. So I will immediately write a 2. Is there anything else common? Yes, there is a 3 common in all of them. So I will write that 3 also. Is there anything else common? No. So just 2 and 3, but we have to take the minimum power of 2. What is the minimum power of 2? It's 2 itself. 2 is the minimum power here. So we have to take 2 square. And what is the minimum power of 3? It's in this one. 3 has a power of 1 here. So we have to consider only 3 to the power 1. That is just write 3. Don't write 3 to the power 1. So this is 2 square, which is 4, and 4 3s is 12. HCF is 12. Everyone got that right? LCM is troubling some people. So you have to consider all the factors. So 2 is a factor. Write that 2 over here right away and take the highest power of 2. What is the highest power here? 3 is the highest power. So you write 2 to the power 3. Then 3 is another factor. Write that 3. And what is the highest power? We can see 3 is the highest power again over here. So we will take 3 to the power 3. Then 5 is there, and 5, there's only one of them. So 5 has a power of 1. So we'll write just 5. And again, 7 is also a factor. So we will take that 7 also. Don't forget to multiply this 5 and 7. Okay. So when you multiply all this, you should get 7560. Okay. Good. Fine. So let's take some more questions, different type. Which question is this? Question 4. So both read the question and tell me who understands what needs to be done here.
Sir, we need to subtract that 5 from both the numbers and then find the HCF.
Yes, very good. They're saying that you want to find the largest number which will divide them, but not these numbers, just like that. They're saying that once you divide it, it should leave a remainder 5. So when will it leave a remainder 5? When you find some number which is 5 less than that, like 240. Okay, there is some number x which divides this 240 exactly. That means if you divide this number with 245, that is 245 divided by x, then you will get a remainder of 5, correct? If 240 is completely divisible by x, then of course, when you leave 245, when you divide 245 by x, you should get a remainder of 5. Is this idea making sense? This is very simple. Do you want me to explain it in more detail?
Yes, sir.
Okay, I will explain this. Let's say let's take an example. 68. Okay. I'm asking you to find the number which will divide this and leave a remainder 5. So what will you do if you want a remainder 5? I will just go through the whole process once and then it will start making sense. Okay. If you want the remainder to be 5, what you do, you don't look for the factors of 68. Okay. Because 68 is not divisible by my answer. Okay. I'm asking you to find the number which when you divide, it should leave a remainder 5. That means you subtract that 5 from the number here. That is 68 minus 5. How much is that? 63. Now this number should be divisible by your answer. Okay, so hold on. I will explain this with complete formula also, but let's just see if you can understand directly using simple logic. Okay, so 68 minus 5, it gives you 63. Now you know 63 is divisible by 9, right? So now try dividing 68 by 9 and see whether you get the remainder 5 or not. You will get 9 sevens are 63. So of course we know that 63 is completely divisible by 9. That's why we chose. And when you subtract it, you will get a remainder 5. No? Okay. So by now you should believe that, okay, whatever sir is telling, that is correct. Okay. If we want to have a remainder 5, we have to subtract 5. But why do we have to do that? So let me give you logic for that also. You know division algorithm, right? Dividend is equal to divisor into quotient plus the remainder. See what they have given you.
Completed, sir.
Okay, that's good. So what they have given you is, they have told you that there is a number 68, and when you divide this 68,
Can you once again show that question, sir?
yes, 245 and 1037. It should leave a remainder of 5. Further question? Can I scroll down?
Yes, sir.
All right. So understand that I gave you the number 68 and I told you to find me some number which is divisible, which is not divisible, but it will leave a remainder 5. So what you do, you move the remainder to the left hand side. That is 68 minus 5. That should be equal to your divisor into quotient. So now this number 68 minus 5, it is completely divisible by your divisor, right? Because divisor into quotient gives you that number. Does it make any sense?
Yes, sir.
So it should be 9 into 7 and that will become 63. Okay. So the same logic we have to apply here also. If you want to have a remainder 5, that means you have to subtract 5 with all the numbers. Yes, tell me.
Sir, I have completed it.
Okay, that's good. Just a minute. Yeah. So what do? 245 minus 5, you get 240. And then 1037 minus 5, you get 1032. So these are the numbers which will be exactly divisible by your number. Now, how do you find the number, highest number? They are saying largest number. Find the largest number which divides both of them. That means they're asking you to find the HCF of these two. So do that, and what do you get? How do you?
24, sir.
Okay. Tell me how you expanded 240.
2 to the power
3 into
4
2 power 4
into
into
3.
Okay, one person at a time. So Ritesh, you will tell me.
2 to the power 4 into 3 into 5, sir.
Yeah, always make a habit of writing in the increasing order of the prime factor. 2 first, then 3, and then 5. Okay. Write it in that order. It's important. 2 to the power 4 into 3 into 5. All right. Then 1032. How do you expand this? Who will tell me?
Shall I? Sir?
Yes, go ahead.
2 cube into 3 into 43.
2 cube into 3 into 43. Is that right?
Yes, sir.
Yes,
Okay. So what is the HCF? Tell me. Who will tell me?
2 power 3 into 3.
Yes, 2. 2 is a common factor and the lowest power is 3. So we will take 2 to the power 3. And 3 is also a common factor and the lowest power is, both of them are 1 only. So we'll take into 3. There is no other common factor, so we'll ignore those two. So what is it?
24.
24, sir.
8 3s are 24. Okay, very good. Everyone has got it, I think. Let's move on to the LCM. Now tell me, what about LCM?
Sir, but they are asking only the largest common.
Oh, I'm sorry. Yes. I went into a flow and I forgot about the question itself. You see, that happens to me also sometimes. Okay, so here we just had to find the HCF. No need to find LCM here. That's good. Okay, so HCF is 24. That means when we divide these numbers 245 and 1037 with a 24, you will get a remainder 5. You can try to check it at home, do the division at home and see whether you get 5 or not. Okay. By subtracting 5, we got 240 and 1032. So 24 completely divides 240. So of course, when you divide 245 by 24, you should get a remainder 5. Okay, I want all of you to go through the question once more. Read the question once again and see what you did. And remember this type of question. Okay, so now in this question, both these numbers left a remainder of 5. So you subtracted 5 with both of them. But there may be questions where they might ask you to find a number which will divide and leave different remainder with these numbers. So let's take one question of that type also, just to make sure. Okay, so here they're asking you to find a number, largest number, which when divided will leave the remainder 3 and 5 respectively. Means 129 when you divide, it should leave the remainder 3, and 545 when you divide, it should leave a remainder 5. So what do we do? Tell me, someone.
We have to subtract 129 with 3 and we have to subtract 545 with 5.
Yes, you have to subtract 3 from 129 and subtract 5 from 545. And then whatever you get, both the numbers, you'll have to find the largest common, the highest common factor, that is the HCF. So do that very, very fast, quickly, all of you. Let's see if who can beat me. I will try to do in slow motion.
Sir, this is fast, sir.
Is this? Do you want me to really do the fast? Okay. Okay, I'll slow down a bit more. Let's see.
Completed, sir.
Okay, good. Just hold on. Anyone who completes, let me know.
Completed.
Sir.
Okay, I heard Kavya, Ritish, and Pragati. Is that you?
Completed, sir.
Who's that? Tanushri?
Yes, sir.
Okay, good.
Completed, sir.
Completed, sir.
Okay. Good.
Completed, sir.
Right. Oh, I should have taken 540, not 545.
Completed, sir.
Okay, good. Yeah. So how do we write 126? You know that it can be written as, Tanushri will tell me 126. How did you write it? The factors, tell me.
Sir, 2 into 3 power 2 into 7.
Okay. Adi, tell
Sir,
me.
I'm 4.
Adi will, no.
Okay, sir. Okay.
Yes, Adi, tell me.
2 square into 3 cube into 5.
Okay. Manoj, tell me what's the HCF?
2 into 3 power 2, sir.
Yes, so 2 is a
18,
common,
sir.
yeah, 2 is a common factor and the lowest power is 2. And 3 is also a common factor. And lowest power is 3 to the power 2. So this is 18. Everyone got 18? Confirm, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So 18 is the number which you, when you divide this 129 and 544, it will leave a remainder 3 with 129 and it will leave a remainder 5 with 549. Okay. 545, I mean to say. So you can write the summary of that answer also at last. Okay, so I think you people now understand how to handle this remainder thing, right? Even if the remainder is same, you'll subtract the same number from both of them. And if they're saying that the different remainder should be there, you will subtract each of them separately. 129 minus 3, 545 minus 5. So you should be able to handle these type of questions also. All right, so that's it for the maths class. Anyone has any doubts from today's class?
Yes, sir.
No, sir.
Ritesh, you have a doubt? Tell me.
Sir, third question, sir.
First question.
Third, sir.
Third one.
Yes, sir.
Find the HCF and LCM of 108, 120, and 252.
Sir, LCM into HCF, what will be there, sir? Product of
For-
three numbers, sir.
Okay, the product of, no, it will not be like that. See, it doesn't work. For two numbers, it works like that, not for three numbers. For three numbers, the formula is different. Okay, so that's good. If you're interested to know that, see, just now we saw, and yesterday also we saw that HCF and LCM of two numbers A and B, when you multiply, they are equal to the product of the two numbers. So you might think, okay, if I take HCF of three numbers A, B, C, and if I multiply the LCM of the three numbers A, B, C, will it be equal to A into B into C? No, it doesn't. Okay, it's not equal to that. So you don't need to study this from exam perspective, but the formula is there at the end of your NCERT book. Okay, let me show you the formula. Okay, you see here, this is your formula basically. So if you have three numbers PQR, the LCM, you can take it like this. So basically what they're saying is P into Q into R will be equal to, you can find it from this formula, no? What is PQR equal to? LCM into this HCF of all these individual pairs.
Sir, is that a quite lengthy?
Yes, it is lengthy and you don't have to remember this. This is not for your exam. You will not get questions like this. This is just for information, okay? Okay, any other questions, guys?